Hi everyone, welcome to Machine Learning Laboratory, program number 4. Here in this program, the program statement is build an artificial neural network by implementing the backpropagation algorithm and test the same using appropriate data set. So this is our problem statement. We need to develop an artificial neural network by implementing the backpropagation algorithm. We shall start our program now. See, before starting our actual program, here we need to understand several neural network concepts that are important before starting our program about the backpropagation algorithm. The first one is inputs. So, input is nothing but the source data which is fed into the neural network with the goal of making a decision or prediction about the data. Here the data is broken down into binary signals, so which is used to allow to be processed by the single neurons. So this is a simple information about the input. The second one is training set. This is a set of outputs for which the correct output are known. So these can be used to train the neural networks. And the third one is output. Output of the neural network can be a real value between 0 and 1 or a boolean value or a discrete value or continuous values. For example, is a category ID or whether the output is a male or female. So these are the examples of output. Next one is our activation function. See here, each neuron accepts part of the input and passes it through the activation function. So here we have used some of the commonly used functions are the sigmoid function. So these activation function normalizes the output to give a range which to ensure the model has stable convergence. And the fifth one is initialization of weights. Here every neuron or each neuron is given a numeric weights. The weights is applied to the activation function, determine each neuron's output. So in the training of the neural network learning model, the objective is to discover the weights that can generate the most accurate outputs. The next is with respect to the initialization of weights is setting the weights at the beginning. So before the model is trained, we have to set the weights. So there is a typical strategy in neural network is to initialize these weights randomly and then start optimizing from there. So this is all about the initialization of weights. Next one is forward pass. Forward pass in the sense, this forward pass tries out the model by taking the input, passing them through the network and allowing each neuron to react to the fractions of the input and generate an output respectively. So this is about the forward pass. The next one is gradient descent. So gradient descent, it is a mathematical technique that modifies the parameters of the function to descend from the higher value of the function to a low value by looking at the derivatives of the functions with respect to each of its parameters and seeing which steps is the next best step to minimize the function. So this applying the gradient descent to the error function which will help to find the weights and achieve lower and lower error value and making the model gradually more accurate. So these are the basic information that we need to know before starting the backpropagation algorithm. See, we have different stages of neural network learning. See, these are the steps which are generalized for the neural network learning. See, this neural network learning model training occurs in 6 stages. The first stage is the initialization. What it does, in the initialization stage, we initialize the weights which are applied to all the neurons, and these weights are taken randomly. The next step is forward propagation. The input from a training sets are passed through the neural network and an output is computed. Third step is error function. See, because we are working with the training set, the correct output is known. So the error function is defined that will captures the delta value or difference value between the correct output and the actual output of the model by giving the current model weights. So this is the third step. And the fourth step is the objective of the backpropagation is to change the weights of the neurons in order to bring the error function to a minimum. This is our fourth. And the fifth is weight update. Weights are changed to an optimal values according to the results of the backpropagation algorithm. And the last step is iterate until convergence, because the weights are updated a small step or delta step, or can also be called as a learning rate at a time. So several iterations are required in order for the network to learn. So after each iterations, the gradient descent forces updates the weight towards the less and less global loss function. So the amount of iterations needed to converge depends upon the learning rate or the network meta parameters and the optimization method which is used. So at the end of this process, the model is ready to make the predictions for unknown input data. So the new data can fed to the model, a forward pass is performed, and the model generates its predictions. These are the 6 stages of neural network learning. Next, we shall see the algorithm of backpropagation. So now let's discuss about the backpropagation algorithm. So here the backpropagation algorithm is fed with the parameters. The parameters are the training examples, learning rate, total number of input nodes, total number of output nodes, and total number of hidden nodes. Nodes are nothing but the neurons. So the first thing is each training example is a pair of the form x comma t. Here where x is the vector of network input values and t is the vector of target network output values. Next is eta. It is called as learning rate. Here the learning rate is kept as small as possible. Here some example is 0.05. Here ni is the number of network inputs, n in. N hidden is the number of units in the hidden layer, and n out is the number of output units. And here the notation is the input from unit I into unit j is denoted as x j I, and similarly the weights from unit I to unit j is represented as w j I. So these are some of the basic information which are required for the algorithm. Now let's see the first step. What is the first step? you need to create a feed forward network with Ni, that is with n inputs, n hidden units and n output units. Let's consider a simple example here. I will take two input nodes and this is called as input layer, and next one is hidden units. Here I take three hidden units or neurons in the hidden layer. This is represented as H, or it can be represented as N hidden. There are three hidden nodes or neurons are there, and the output is I take one output nodes. So each and every node, that is in the input layer, each and every node is connected with the hidden layer nodes. You can see here, for this is your input node 1 and this is your input node 2. Similarly, for the hidden layer, the I2 is also connected to the hidden layer, and the nodes in the hidden layer is connected to the output layer neurons. Here there are three hidden nodes are there in the hidden layer and one output node is there in the output layer. So this is our first step, that is creating a feed forward network with n inputs, n hidden units and n output units. Next step is initialize all network weights to small random numbers. Here for every connection, that is from I1 to J1, J2 and J3. These are the hidden layer nodes and O1. This is output node. Here for every connection from I1 to J1, weights are initialized, that is W, J1 and I1. So this is how we denote. Similarly, for all the connections from input layer to hidden layer and hidden layer to the output layer, the weights are initialized with the small random numbers, and you need to perform some steps repeatedly until there is a termination condition is met. So what are the steps are we shall see now. The first step with respect to this loop is, for each and every training examples you need to follow the first steps. The first step is you have to propagate the input forward through the network. Means you have to propagate the input instance, which is denoted as X, to the network and compute the output. Output is denoted as O. Here you can see that OU is represented as a unit. For every unit in the network, you need to identify the output. The next step is propagate the error backward through the network. How do you identify the errors? That we'll see that now. The network, for each of the every network output unit, we need to calculate the error term. Means here I need to identify what is the error which is occurred at this output. You need to identify the error term, that is do k. How do you identify here? This is the formula. This is for just an information. Actually, we use this formula to identify the error term which is at the output node. Next one is, similarly, we have to identify the error term at the hidden unit. It is denoted as DOH, and for that unit, this is the formula to identify. And here we need the weights need to be updated. That weights, how do you update? That weight is updated with these formulas. So these are the steps of backpropagation algorithm. Now we shall see in detail how it works with respect to the program. So let's see the program here. The program starts with importing the NumPy, that is the data frame here, and also we have two inputs for our network. One is sleep and another is steady. So that is denoted as 2 hours of sleep and 9 hours of steady. This is one instance, and another instance is 1 hour of sleep and 5 hours of steady. Similarly, with the third instance, that is 3 hours of sleep and 6 hours of steady. This is our input to our network, and the output is, that is expected output is 92%, 86% and 89%. So the detailed information about this program with the explanation is given in the text document, which is mentioned in the description link. You can visit that and you can download the entire description of the input of this artificial neural network program. Here the third line gives use to normalize the data, and here Y is used to convert this data, that is output data, in the form of fraction values. That is you can see here the output is, expected output is 0.92. It is converted as 0.92, 0.86 and 0.89. So this is the value which is stored in Y. So this artificial neural network program uses the normalization. Okay, so why we need the normalization? The normalization is used to change the value of numeric columns in the data set to a common scale without distorting the difference in the range of values. So this normalization is a good technique to use when you don't know the distribution of your data, or when you know the distribution is not the Gaussian values. So normalization is useful when your data has varying scales and the algorithm you are using does not make any assumptions about the distribution of the data. So this normalization is used in our artificial neural networks. So this is the information why we need normalization. And next one is, we need some of the variables that need to be initialized. The first is epochs. Nothing but you are going to set how many iterations are required for our program, and this is the learning rate. The learning rate is denoted as LR, which is kept as low as possible, that is 0.1. And you are going to create a neural network where the neural network consists of 2 neurons. Hence it is given as input layer is equals to 2. That is why we have required 2 inputs. Here you can see here 2 hours of sleep and 9 hours of steady. Means these are the 2 inputs which are given to the network. And how many output is there? Only one output for our program. That is, if I study for sleep for 2 hours and if I study for 9 hours, and the expected results in the examination would be 92%. So here I have created a network which consists of 2 neurons and 1 output neuron. 2 input neuron and 1 output neuron, and here you can see here 3 hidden neurons. So I have already explained how we select the neurons in the hidden layer depending upon the problem complexity. And next step is we need to initialize the weights and the bias values. The weights are from input layer to the hidden layer and hidden layer to the output layer. So we need weights from the input layer to the hidden layer and from hidden layer to the output layer. Hence you can see here WH is nothing but a weight of the link from input node to the hidden node, so which are taken randomly. So similarly we are going to use the bias value, means we need to initialize the bias value at the hidden layer. So what the bias value is? The bias is from the link from input node to the hidden node. We need to initialize the weights of the link from hidden node to the output node, and B out is nothing but your bias of the link from hidden node to the output node. So these are the sum of the initialization of your artificial neural network. And the next step is, so now we use the sigmoid function. So as you know that sigmoid function is one of the activation function. So what the activation function does? Activation functions of a node in a neural network which defines the output of the node given an input. So here there are some of the activation functions are there. One could be the sine function, step function, sigmoid function. So we have used a sigmoid function. Sigmoid function which is plotted as a S-shaped graph, and this is the formula for a sigmoid function which has been defined here. And we have defined the derivatives of sigmoid. So why we need derivatives? When updating the curve, to know in which direction and how much change or update is required, that has to be identified. So for that the derivatives has been defined here. So next is the forward propagation, backward propagation, and how much hidden layer weights contributed to the error. So all these steps that has to be repeated for 5000 times. So here in the for loop the epoch is we have initialized with 5000 values. So here H input 1 is nothing but you are using a dot function. This in a NumPy module which provides a function called as a dot function, which is used to perform the dot product of two arrays. So here X is nothing but your inputs and it is multiplied with the weights, and whatever the result which we received is added with the bias value, and the same is given to the sigmoid function of a neuron which is in the hidden layer. Similarly, we do perform the same operations for the neurons which are at the output layer. So we need to identify the backpropagation. So here the errors are identified at the two layers. One is to identify the error value at the output layer and also at the hidden layer. So this is we have done. And similarly we need to identify how much hidden layer weights that will contribute to the error. That is done with these functions. And also you are going to update the weights at the output layer and also with respect to the hidden layer, that too with the weights. So that is done by these lines. So
you are going to print actual input, actual output, and you are going to print the predicted output. Let's see the output of this program. So in this program, if I run this one, so you may get different values for different run, because every time when you run the program, the weights are taken randomly. So here you can see the output of this program. The input has been normalized, and this is an actual output that what we have defined, 0.92, 0.86 and 0.89, and the predicted output would be the 72, 0.72, 0.71, 0.72. And if I run once again the same program, you may get different values. As I already said that, so you can see here you have a 70.72, here you have 0.74, because every time you run the program, the weights are taken randomly. So this completes the program number 4. Thank you so much.